The negative binomial. Both of these equations attempt to solve the same problem, but they're a little bit different in a very small way. And in this video, we're going to discuss how they're different and solve a simple problem that will make the differences a little bit more clear for you. I remember when I studied this in statistics, this confused me because on the internet I learned equation A. We'll call this version equation A, and I learned this version in class, and what x was, it was just kind of confusing to me. Anyways, in equation A, what x represents the number of trials. Equation B, x represents the number of failures. They're very subtle differences, but they will affect the outcome. Trust me, you don't want that pain that I went through. Now with equation A, what we're trying to figure out with this negative binomial is the number of trials before the rth success, where in equation B is the number of failures before the rth success. Say we have 5 trials for equation A. We know that this last trial is going to be a success. So we are only concerned about the first x minus 1. If this represents x, our number of trials. So let's do a quick problem, and it should make the differences clear for you. In this problem, we're asked, or we're told, a family decides to have children until it has 3 children of the same gender, assuming that the probability of a boy is equal to the probability of a girl, which is equal to 0.5. So you have a 50% chance of getting a boy and a 50% chance of getting a girl. What is the probability mass function of x equals to the number of children in the family? Probability mass function, just remember, it represents discrete random variables, whole countable things, so not something like time. So this is perfect for a negative binomial. We're looking for the number of trials it takes until the family has 3 children of the same gender, or the number of failures until they have the same gender. So writing these equations down, remember it's just x minus 1, r minus 1, the probability of success times the probability of failure. And the reason we're subtracting off r is because this should represent the number of failures, and if we have x trials minus r successes, that would give us our number of failures. However, in the second equation, equation B, where x is the number of failures, we are going to add the number of successes and subtract 1, and then r minus 1. Now this is saying the number of failures plus the number of successes minus 1. So you can see there how they're the same thing, just written different ways. And we will do the probability of success times the probability of failure. And now this is another difference. We only have to write x up here because this is the number of failures, where this was the total number of trials minus the number of successes to get failures. X already represents the number of failures. So tackling the problem, we're looking for the PMF, which is the probability mass function, which would look something like this. X, our random variable, and the probability of that. And we can stop at 5 because we know at 5 they would have achieved their goal of having 3 children of the same gender on that 5th attempt. However, for the 0, 1, 2, the probability of having 3 children of the same gender is going to be 0, because you can't have 3 children if you've only attempted to have 2 children. So the probability is 0. Using equation A, we will use the number of trials, which is 3, minus 1, number of successes, we are looking for 3 children of the same gender times the probability of success to the power of success, which is 3. We don't have to subtract 1. Times the probability of failure, which is 1 minus 0.5, which is 0.5. And to the number of trials, which is 3, minus, take away the number of successes. So this is just 0, which is going to bring us to an answer of 2 choose 2, which is just 1, 0.5 to the power of 3, and 0.5 to the power of 0, which is just 1. So what we actually have is just 0.5 to the power of 3, which is equal to 0.125. However, this is not the answer for this question. This merely represents the probability that you did one of these. We're looking for the probability that you either got 3 boys, or, keyword or, the probability that you got 3 girls. So while this represents one of those situations, we need to add to it. So it's going to be 0.125 plus 0.125, and our answer is 0.25. And that is the answer for this. Now let's look at our second equation, equation B, and how we'll get the same answer. So if we look, our number of failures, well, if we successfully get on the third try, there will be 0 failures, plus 3 successes minus 1, 3 minus 1. Remember, the reason we're subtracting 1 is because we know on that final attempt, on that final trial, it will be a success, because that's why we stopped the experiment. I guess you could call it an experiment. So the probability of success is 0.5 to the power of 3, and 0.5 the power of the probability of failure to the power of failures, which is 0. And we know that this would be 2 choose 2, which is just 1, times the probability of success, power of 3, and again 1. And when you look at that, it is as well 0.125. But remember, this is only one of the values, so we have to OR them, and this would be 0.25, which is, as you can see, the same answer. Now let's do number 4 quickly. So using equation A, we're looking for the number of trials, so 4 minus 1. Our successes is still going to be 3. We're looking for the first 3 children of the same gender, minus 1, times the probability of success to the power of 3, probability of failure. And now x in this equation represents our number of trials. We have 4 trials, minus r, the 3 attempts. So this comes out to 3 choose 2, the probability of success again, failure, 4 minus 3 is going to be 1. So this comes out to we get an answer of 0.1875. But remember, this is just for the 1, so we have to add to it, or multiply it by 2, and we get the answer 0.375. Well, it's a little tight in there. And then finally, we'll just do it with equation b quickly. So remember, with equation b, it's our number of failures. So our number of failures in this case is going to be 1 plus 3 minus 1, and then 3 minus 1. Number of successes. Number of failures, remember it's just 1. You don't have to subtract anything. And we'll get the same thing. And we have to multiply it by 2 or add them together. And as you can see, we will get the same answer. It doesn't matter which version you choose to use, but what does matter is you understand how you're using it and what your random variable, is representing. With equation A, it's the number of trials. X is your number of trials, and you have to subtract off your number of successes. Whereas with equation B, X is your number of failures, and you won't have to subtract off your number of successes because X already represents the number of failures. Alright, I hope this video helped. If you found some use in this, please like the video and maybe consider subscribing. And until the next video,